Hello everyone, I hope everyone had a nice week and everyone is up to date. And this week we'll be meeting on Saturday and hopefully everyone brings a good question to discuss about. So today we're going to talk about the following thing. If I can find my mouse, here we go. So today we're going to talk about digital versus analog. And activity we're going to do street light. So digital versus analog signal. Well, on the left, what signal do you see here? Can anyone recognize? Yeah, it's your heartbeat signal. Okay, this is what your heart gives as a signal saying that it's beating properly. So what are signals? Well, data and information can be delivered by something called signals. Okay, and there are two main types of signals we have, and one is analog. Now, analog signals are made up of continuous values, as you can see on the right. See, as the time goes by, the signal can be moved continuously. It can go up and down, and you can see that there's no gap, right? It's all continuous, meaning you're able to draw this graph without picking up your pencil if you were to draw this, right? So that's what it means to be analog. It's continuous. Now, another example of analog signal is what you see here. It's a light switch, but it's a slider. So as you can see, as you dial to the right or clockwise, it gets darker, right? But it's not on or off. But rather than that, it's actually it's gradient, meaning you can see the continuous change of light depending on where the dial is. So that would be an example of analog signal. Now, analog signal compared to digital signal is less reliable. Now, I want you to think about why that might be, and not necessarily you have to come up with an answer, but just think about it. Okay, remember it can be also converted to digital signal through something called sampling. Don't worry about this, but just know that it's possible to convert analog to digital signal. So, what is digital signal? Well, compared to analog, digital signal has two distinct values. It's either 0 or 1. So if it's 0, you can think of that as off, and if it's 1, you can think of that as wait, did I say off is 0 and on is 1? Okay. Now let's look at this graph here on the right top corner. Now, as you can see here, the graph is very different from analog signal graph, right? Look at this, continuous, right? But now we have rectangular shapes, right? It's either on the bottom or it's at the peak. And between, there's a jump. Now, even though there's a straight line there, it's a jump, okay? It means there's no value between these two. It's either 0 or 1, okay? Now, you can think of this as a light switch that can either be on or off. As you can see here, it's kind of distracting because it's flicking. But anyway, digital signals are, compared to analog signals, they're more reliable. That's why nowadays, most of the signals that we send within the communication device and also within the device is usually digital. And this digital concept of 0 and 1, it's called binary code. Bi means 2. So binary means there are two terms. It's either 0 or 1, and it's a language that we use to communicate with computers. So if you have watched videos or a movie where there's a lot of coding going on, programming going on, you'll see a bunch of zeros and ones, and that's how computers communicate. Now, moving on. I forgot to note here, it's possible to convert digital signal to analog signal, and it's done a lot actually in devices. Now, can you identify which device is digital or analog? Pause the video and think about it, and resume after you're done. Okay, so hopefully you said something like this. The microphone is actually analog, okay? A microphone itself picks up voice, right? Our voice can be in very continuous, have continuous metrics. For example, our volume can be either high or low. It's not on or off. It can be anywhere between. And also our frequency, the pitch, can be also changed so that this device has to be able to pick up analog signal from our voice or outside signal, outside sound. And of course, if you want to analyze this, This analog signal can be converted to digital later on, but the microphone itself is analog. Now, what about TV? Now, TV is a tricky one because why? TV contains both analog and digital. Now, nowadays, the screen itself is digital, meaning when each pixel in your screen is depicting what color it is, it gets signal from the source, and that source signal is digital. It's all 0 and 1s, and depending on the value, it determines what color is how much. But of course, when the sound comes out, it's not digital sound. It's not like on, off. It's actually analog, right? Because the digital signal that contains the sound information is converted to analog signal. So yeah, many devices that we have, they both contain analog and digital. Because why? We use them both. Okay. Exercise 1: identify which signal is an analog signal and a digital signal. Pause the video. Come back when you're done. Maybe this was too easy. The first one is analog, and the second one is digital. Please, there's clear distinction, right? Analog can be continuous. It can have any value between one point to the other, right? But digital can be either 0 or 1. 1 0 0 1 0 1 1 0 0. That's how computers pick up and communicate with us. And this can be challenging, but think about this. Given the following analog signal, think about how we might be able to convert it to digital signal. If you remember, I said digital analog signal can be converted to digital using something called sampling, right? Now, we didn't really talk about what sampling is, but think about how you might be able to do it. Pause the video, come back when you're done. Remember, this is a challenge, so don't spend too much time on it unless you want to. All right. Hopefully you came back after thinking a little bit at least. So briefly talking about sampling, what it does is depending on sampling rate. So sampling rate means how often do you want to sample? For example, let's sample this into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 different sections, right? So what it does is divides into 13 sections, and at each value, right, at each peak, it gets values here. This value is 1, this value is 2, this value is about 2, this value is about 2, this is about 3, and so on, right? So I can write here, this value is 1, this value is 2, this value is 2, this value is 2, this value is 3, and for example, this value is 5, right? And I guess this value is 6, and so on, right? So at each sampling position, each one has a value. Now, even though there's value between here to here, here to here, we don't really care. We only care about positions where we're sampling. So only information that we'll have after digitize this signal, it's going to be 1, 2, 2, 2, 3, 5, 6. So instead of having all this continuous values, we now have distinctive values. But you might be asking, hey, that's not 0 and 1. So how do we convert this to 0 and 1? Well, if you look at these numbers above, those are binary numbers representing 1. So binary number for 1 is 1. Well, the reason why we have 0, 0 is like, well, I'm not going to get into that, but let's say they're just there for placement value. Now, binary number for 2 is 0, 1, 0. If you want to look more about binary number, Google it because it's pretty easy to learn. It's pretty fascinating, okay? Now, moving on 3, maybe we can do that during our meeting time. So 3, you can see that compared to 2, it has one extra 1, right? So 0, 1, 1 means 3. Now, you can guess what 5 is, right? 5 is 1, 0, 1, and 6 is 1, 1, 0. That's how an analog signal can be converted to digital, okay? Bunch of zeros and ones. Now, if you want to watch more about it, please click here and you can watch it with animation. But we're going to move on for now. So input devices. So from what we talked about in Make Kit, right? Hopefully you have the Make It by now. There are multiple input devices we talked about last time, but let's talk about this 4, okay? One is brightness sensor, and the other one is ultrasonic, and the other one is a switch. I guess they're the same. So there are 3 different types. So think about what input device might be what type of signal. Pause the video, come back when you're done. All right, hopefully you guessed something like this. Intensity, analog. Ultrasonic, analog. Switches, the digital. Now, the reason behind it is because light intensity can vary from really dark to really bright, and there are a lot of values in between, right? So it's analog. Now, ultrasonic, if you remember what it does, it measures distance using sound wave, okay? So it has to be able to pick up what distance it is, not just is it far or close. No, no, no. We don't want that. We want exact distance. That's why ultrasonic should be, it makes sense that it is analog. Now, what about switch? Well, this switch are not dial switch. So this makes sense that this is digital because it's either on or off. All right, moving on. So let's get in deeper into light intensity sensor. Now, light intensity sensor, what it does is it senses intensity of light. Now, so as an output, it gives a value from 0 to 100, and closer to 100 simply means something the outside sensing light is really bright, and as you get lower to approaches to 0, that means it's dark, which makes sense. Moving on, ultrasonic sensor, what it does is it sends out sound wave. Now, when the sound wave travels along, like away from the sensor, when an object is obstructing the path of the sound, what it does is the sound reflects backward. It comes back to the sensor. And depending on how fast that happened, the sensor calculates how far an object might be located. Okay? So I guess I gave away most of the answer, but think about why it makes sense that ultrasonic wave sensor should be an analog, not digital. All right. Hopefully you're thinking about, well, in order to measure distance from varying distances, it makes sense that ultrasonic wave sensor should be an analog sensor. Okay. Now, the reason why we emphasize on analog versus digital is because if you look at your Arduino board, right? Now, I'll talk about this more in detail very soon. There are two different inputs. If you read through here, it's called digital sensors. And if you look at the bottom part, it's called analog sensors. So depending on what type of signal each device uses, you have to put the pin in the right position, okay? And I will go into demonstrating how to build a street light. Hi, here I'm going to show you how to build traffic light using MakeKit. You're going to be needing Arduino board, breadboard, and LED lights with jump wires. All right. So I'm going to be using Make App and just follow along. Now, if you have already built this, then you may skip this part because I want to make sure that everyone is able to do this, because even the later projects, it's all based on this. All right. So first thing is I'm going to be following along the direction, and it says to connect the Arduino board with the breadboard. So to be consistent, I'll be making sure that the top part of the breadboard is negative and the bottom here is going to be positive. The negative part will be connected to the ground. Now you may see multiple grounds. It doesn't really matter which one. I'm going to use one of them. And for the positive side from the breadboard, I will be connecting it to here, Arduino board, 5 volt. Okay, so let's do it. You can see that yellow is connected to 5 and black is connected to ground. That means all this positive will be connected to the power supply from the Arduino board. Okay, and all this row of negative is connected to the ground. Okay, the next thing is going to be attaching LED lights. Because the longer side is positive and the shorter side is negative. Okay, so I'm going to make sure that all the positive sides are right. It doesn't really matter which way, but I'm going to just be clicking. Oh, it's very not focused. It will be focused very soon. There we go. So as you can see, all the LED lights are now connected to the breadboard. So that means when I connect the wires, I have to make sure that I use the same row. Okay, so that will be the negative side, and this will be positive side. Okay, and that's what I'll do. So what I'm going to do is I'm going to be connecting the negative side to the minus part. Okay. So what have we done? We have connected all the negative side of LED to the negative row that we talked about, because that eventually connects to the Arduino board negative side. Okay. Now let's connect positive sides. Now for the positive ones, we'll not be connecting it to the positive side for now, because we want to make sure that we're able to control which one turns on. So according to the app, green one, this is green one. Look, this is green one, right? Green one will go to number 9. So if you look here, where's number 9? Number 9 is right. Oh, let me focus. Do you see the number 9 is right there? And do you see that this is digital? LED is digital. So we're gonna put our pin right there. Good. Yellow one is 5. So this is yellow one. Go to number 5. Do you see number 5 right there? So number 5. And lastly, the red one goes to number. Red one goes to number 5. Yellow goes to number 6. So I just replaced number 5 to 6 for yellow. This is yellow. And this is for red one. So it goes to number 5. I'm just trying to be consistent with the make app. I mean, there we go. So what's happened now is we have connected all the LEDs, right? We grounded all the LEDs. And positive side, we have connected to our outputs from Arduino board in digital side. Now what we have to do is we have to connect this Arduino board with a power connector, okay, power source, and easy to do. And on the other side, you have to find your own, like the appropriate adapter. I'm gonna be using USB-C, so it looks like this at the end, and I'm gonna be connecting to my computer. Okay. Oops. Now once you connect, you can see that there are red lights. Now on the top it's power, on the bottom it means it's ready to go. And let's use our code from last week and run this simulation. So now let's check out the screen and let's check out the block coding that we have and think about what might happen if we run this. Right. Now, to unload this, you just have to find the up arrow button on the top right corner, click it, select Arduino Uno, and upload. And when you upload, you should see the board blinking, as you see now. Do you see that? That means it's receiving. And now what we're going to do is we're going to check out what's actually happening with the LED light. Now, hopefully you have guessed it right. Green, yellow, 2, 3, red, green, yellow, 2, 3, red, because we repeated blinking of yellow light 3 times. Now this is a very simple coding, a simple project, but I hope you had fun with this, and we'll be making more complex, more complicated ones using other sensors like ultrasonic and also brightness sensor. I'll see you on Zoom meeting this week, and hopefully see you next week as well through YouTube video. Thank you everyone. Have a great week. Bye bye.